Hi everyone, we're going to evaluate the given definite integral over the interval 0 to 1. And we're going to look at this form here. It has this form here without the square roots. So what I'm going to do is just use substitution and let x equal tan of x. Therefore, dx equals secant squared, let's do theta, d theta. So this should be theta, sorry about that. And let's go ahead and substitute. So when you do that, we're going to first have to change our bounds. So if we want x to be 0, so let's do that over here. 0 equals tan of theta, so theta has to be 0, because this is our restrictions from negative pi divided by 2 and right here, and pi divided by 2. So quadrant 1 and 4. So that means we're going to start with 0 here. And for 1, we have tan of pi divided by 4. So this is pi divided by 4. So remember, you have to change your bounds when you do the substitution. All right, so let's get started. We know dx is secant squared theta d theta. And we also know that x is tan, so that's going to be tan squared theta plus 1 squared. So simplifying further, we're going to get pi divided by 4, 0. Let's just write the numerator and simplify the denominator. So that's going to be secant squared theta squared using your Pythagorean identities. And this equals, let's see, this is going to be secant squared theta d theta divided by secant fourth of theta. And simplifying that, we get 0 to pi over 4. And this is just going to be 1 divided by secant squared theta. And I'm going to put the d theta here. And that's going to end up being cosine squared. Theta d theta. All right, now that you have that, we can evaluate. Well, I think let's rewrite that again. So we have 0 to pi divided by 4 and cosine squared of theta. So remember, when you have the square here, the best way to integrate cosine and sine is to use your half angle formula. So that we can just substitute that identity, which is going to be 1/2 1 plus cosine 2 theta d theta. All right, now let's integrate this. So we're going to get our 1/2, and this is going to be theta plus integrate, the antiderivative of that is 1/2 sine of 2 theta, and we're evaluating it from 0 to pi divided by 4. So let's first plug in pi over 4. Substitute theta for pi over 4, so that's pi over 4. And then sine of 2 times pi divided by 4 is sine of pi divided by 2. So that's 1. All right. Now, when you plug in 0, you're just going to get minus 0 the whole thing. So we're going to end up getting pi divided by 8 plus 1/2. And that's your final answer. Thank you. Have a nice day. Bye-bye.